My name is Jens Pillgram-Larsen. I work at LinkedIn. In about 6 months or so, I'll work at Microsoft, apparently. So be happy to take questions about that towards the end as well. So I spend my days, and I've spent now the better part of a decade thinking about developer tools. One part of UX would be don't let your operating system go to sleep while in presenter mode. That would be kind of a good thing, although Apple generally has very good UX. And that's what I'm going to talk about in this context of developer experience. So Janelle, who's sitting here, spent some time thinking about and talking about developer experience yesterday. And she was focused on the developer experience for the software engineers of today. And what I'm going to talk about is the developer experience for the application developers of tomorrow. And you'll notice I don't use the term engineer and I don't say software, because I think that we're starting to see a shift from people, really writing software programming languages, being engineers, to being application developers. They have some idea, some product they want to get out. And really, iOS and Android has been the first movers in this space. So I think one of the reasons why conferences like this are growing, and like DockerCon was just earlier this week, and there's more and more of these conferences and people interested in developer infrastructure, because we are in a golden age. If you really look back in the last 5 years, what has happened in developer tooling, developer infrastructure, it's truly been transformational. So you have Docker, of course, lightweight containers. Virtualization was great, but it was very, very expensive and slow. You had a lot of process overhead. Docker or lightweight containers really takes care of some of that. Speaking of Microsoft, we're exiting the PC age. We're exiting the Windows age. So that's really come to bear as well. So in every golden age, there's kind of a promise. There's some big transformation that's happening. And I believe the promise of this golden age in software development or application development is democratizing software development. So today, if you go to a company like LinkedIn and you look at like the average resume of a software engineer, it would be something like, at 2, he started building with building blocks and Legos. At 5, he was interested in computers. At 9, he had built his first computer, and by 15, he was spending all his nights, playing Counter-Strike and World of Warcraft and Battlefield and doing things like that, and really interested in engineering and what's going on inside the computers. That also happens to be my resume, by the way. So that is the software engineer of today. You go now and you look into the future, what does the application developer's resume look like? It goes something like this, I think. At 2, she or he got her first iPad and started swiping and going online. At 5 or 7, they started playing around with whatever the Facebook, Snapchat, Instagram of those times are. They learned in school. Their educational experience was on a computer. And by the way, they have no idea what happens inside the computer. It's like CPU, something like, yeah, that's the brains of the computer. Memory management, yeah, those are the brain teasers their parents, made them go to Kumon or something to do. Totally different demographic. And that's the demographic I think we need to start thinking about and designing for. And really what we need to do is start working on making ourselves invisible. So just like we don't think today a lot about what's going inside these, the computers that we have today, like it is almost heresy to use this computer to do a slideshow presentation because of what it really could do. This could, take us to the moon. Any of these computers that we have. And we just don't think about it. It's like, of course you have a retina display and you have 64 gigabytes of memory inside this thing, and you just do that, you have access to almost unlimited computing resources in the cloud, which, as my friend Ethan over here likes to say, is just somebody else's computer. So with every golden age, there's kind of pitfalls. There's a problem. So this is perhaps an extreme example where during the golden age of Rome, the Pax Romana, the Roman peace, if you were Christian, you would get eaten alive by wild animals. Not very pleasant. But I think the analogy goes on. There's some severe pitfalls in this golden age, and that's what I'm going to talk about. I'm going to argue that the biggest pitfall is that we all suffer from a curse of knowledge. We all design and build software development tooling for us, for software engineers, for people who are knowledgeable or clueful about these things, who understand compilers and ASTs and symbol tables and virtual machines and CPUs, etc. And we don't spend enough time being product advocates and thinking about what are our customers' skill sets. So there's this gap. We are on one side of this gulch, and our customers or our users of tomorrow are on the other side. And those poor users keep experiencing that. This is so simple, you just change it. Oh, you're missing a semicolon here. Oh, you can clearly see that this is leaking memory. I mean, come on, right? And so we're talking one language, and they're talking a different one, and we're not connecting today. So I want to spend some time thinking about what does a great product look like in the developer infrastructure space, for an application developer. And it starts with the basic functionality. And of course, IKEA is a great example of basic functionality. You get this flat top box, set top box, and if you know that there is a furniture in there somewhere. And if you get it unpacked, I mean, you can never get it packed again, right? And the instructions are some ungodly amount of visual things, and it's like, hold this at 90 degree, insert doodad A into panel B, and screw, counterclockwise, and it will work. So it's painful. The engineering model is right there in your face. And at the end, if you're successful, you will have a working furniture. There now also, you can go on TaskRabbit and things like that and find IKEA assembly experts that will come to your house, and you pay them by the hour to assemble your IKEA furniture. So that's an example of the abstraction layer I'm talking about. But it works. It's basic functionality. It's cheap. The IKEA of developer tooling is Git. So Git is fantastic. You can do everything. We had this conversation at lunch yesterday, and it's like, yeah, I mean, last week I had to go and rewrite all the history. And it's like, you had to do what? You have a version control system, and you need to go rewrite the history? Isn't that a little dangerous? Like, doesn't that kind of violate the contract? And here, this is actually from the Git manual. And to you, this might make sense. For somebody who's just trying to build an app, they're trying to build a software-based product, this is complete gibberish. I mean, I don't understand this. And it just doesn't make sense. And by the way, there's hundreds of these Git subcommands to be like, here, you can manipulate this. Yesterday, I was in the kitchen at LinkedIn in the morning, and we've been having some problems with our Git store. We have tens of thousands of Git repos in our Git store. And it turns out that 9 of them have gotten corrupted. And out of those 9, 2 of them no longer have a head pointer. Like, head does not exist. And they're like, oh, yeah, of course, but it'll be OK. We'll just run Git garbage collection on it, and we should get head back. And it's like, what are you talking about? How does a version control system lose the concept of what is currently head? So that's Git. So Git's just an endless example of this. I had half a mind to actually show you the output of doing Gradle tasks -- all after applying the LinkedIn base plugin. But due to visual constraints, it just simply does not fit. It also, by the way, does not complete. That operation does not complete on some of our biggest repositories. So you can imagine, we're here. in a lot of cases. Here's the engineering model. Here's a tree, a red-black tree, whatever. Go manipulate it. You have all the power in the world, but it's very hard to do even the most simple things. Like, I just want Git to manage my files and my changes. I just want to do version control. Maybe I don't even know about Git or version control at all. I just want to get my work done. So after basic functionality, you might think, OK, well, let's build better UXs on top of this. No, it's not time yet. The next thing is reliability. So all of these systems actually Git, if you look back in history, Gradle, certainly. I started using Gradle when it was in the 0.x days. It did work some of the time, not all of the time. It's way more stable today, or more reliable, but it still isn't where it needs to be. And there's a lot of research, a lot of psychology around 3 nines to 4 nines, so 99.9 to 99.99% of the time. If it works, it feels to you like, yeah, this just works. Our CEO likes to say this: trust is consistency over time. And that's really what we're talking about here. In order to really build transformational products, you have to trust those products. So I remember growing up. I grew up in Norway. It's very cold in the winter. And just one time out of N, when you went out to start the car in the morning, the engine would just not turn over. That doesn't happen today. It's amazing. I mean, it's, minus 30 degrees centigrade, which I have no idea what is in Fahrenheit because I live in California. And the engine just turns over, no problem. Like, I have a car now that doesn't even turn over. It's an electric car, so I don't know what it does when I hit the start button, but it does something. And that's trust. You trust that the car is going to start when you need it to start. You need to trust that these products work when you need them to work. So you've got the basic functionality. You've got reliability. Now you need the scaling factor. So if you're successful in your product adoption, you're going to hit a level where it's like, this doesn't hit a nonlinear scaling factor. So this was for us with Gradle in 2013. We tried to migrate our biggest repository, our old monolith, onto Gradle. And we have 64 gigabytes of memory on the boxes. And Gradle would just eat up that memory and then went into GC hell. So naturally we said, OK, cool, this works. We're going to go do it. So we had to figure out how to fix Gradle while doing the migration at the same time. So your product used to work up to a point. Now it goes the distance. It works within the core domain that it's supposed to work. And there's two faces to the thinking about performance and scalability. You can always buy scalability at the cost of performance, but you need to keep them relatively in check. You need the performance and you need the scalability. So phase one of up-leveling this is enabling scalability and performance by isolating so that you can parallelize and distribute. And up-level the architecture. Get to the point where you can, in today's world, you have to be able to throw instances or machines at the problem. So you need an architecture that works in that context. And then you start your measure, analyze, improve iteration loop, and you get to the point where it's performant enough and it's scalable enough. So this is something actually we're working on with Gradle right now. We're going through these loops. You might notice that every time, or most of the times when there's a new Gradle version, there'd be something in there saying, yeah, we made this faster, we made the configuration phase faster, we made this more scalable. We're moving towards parallel and distributed builds. And the other thing here is, at LinkedIn, we've gotten to the scale where the actual computing resources we use is a lot of money. Millions, tens of millions of dollars. So when you have efficient scaling factors, you gain efficiency. And for us, this is a lot of money. So next comes integration. so you have all these great building blocks. Like Gradle's a great building block, but it's not a system in itself. You can't build a full CI/CD pipeline just using Gradle. You need other technologies as well. You need other building blocks. So you need to start integrating them. You need them all to work together. And this is separate from the integration that's part of your basic functionality. So you will need something in your basic functionality integration with things to work. Like Gradle needed to integrate with, let's say, Java CE and Sync and other compilers and technologies and Maven publishing and things like that. That's part of the basic functionality. But here it really becomes about what are the systems your product needs to be a part of. And all products need to be part of a system or an ecosystem. A good example of this is the CI/CD pipeline. So you need something to do your, manage your builds, something like Jenkins. You need a build system, orchestration, dependency management engine, something like Gradle. You need deployment, Chef and Puppet, so provisioning. You need feature flags, ramping support, things like that. You need a binary repository, Artifactory. So you need to build all of these things together into a system. And this hasn't really happened in the CI/CD space yet. But you can imagine taking all of these things, bundling them into a product, into a system, and then going out and saying, here you go, enterprise, here's the CI/CD system, and you don't have to worry about all these internals. We've taken care of that for you. So I'm expecting someone to go do that and sell it at some point, a la Hortonworks or Cloudera. So finally, we get to the UX part, abstraction and platform. So we have so far given the engineering model, given the implementation to the user and said, here, work with this, work with our engineering model. Now it becomes working with the user's workflows, understanding how they work, and then moving backwards from there into the UX. And also building platforms that allow those users to customize the offering or product in any way they want. So great platforms. Facebook was a great platform. If you look at Facebook's kind of growth trajectory, it really took off once they started enabling people to build applications. So you had your whatever, what is it called, Farmville or something like that. I can't remember anymore. I was never a big Facebook user. But you need these platforms, and you need the great UX, and you need to iterate in this space. And so when you have all these 5 things is when you have a great product. One that the user is simple for the user intuitively understands the product, how to use it to accomplish what they want to do. So it's a long process, and it's an expensive proposition, but I think we need to get there as a developer infrastructure community. So let's talk specifically about the developer experience or the application developer experience. I also wanted you to take a moment to recognize that I am clearly not a graphical designer or in any way endowed with any artistic abilities, which is, by the way, also a key, if you look at the software engineering community, it also kind of goes hand in hand. But boy, I love our graphical designers. They could take something like this and make it so much better. But very, very simple. When you get software or application development to its core, it's very simple, 3 phases. You want to set up your development environment. You want to make some changes. You want to develop. And you want to push your changes. You want them to go out and get into production, whatever that might mean. So very simple at its core. I think a lot of people get lost in the forest or in the trees here, and these get expanded into 100 or 1,000 different things. And it makes a lot of sense to just take a step back, zoom out, and look at it from this level. So you want to set up your development environment. Okay, something that everyone in this age, in the computer age, and has grown up with computers knows how to do, is essentially go to a menu and say, file import or open. In this terminology, I'm using the word workspace because I'm saying this could be a monorepo, it could be multi-repo, it could be, but it's some logical slice of code that you want to work on. It's an app. It's the unit that the developer cares about, not the unit that the tooling cares about. And then once you have it, you want to set it up. You want to get daemons fired up. You want to get caches warmed up. The application should start and be in like a hot reload mode, where if you make changes, you automatically see those changes reflected immediately. You see what you're doing. You get visual feedback. And then you want more than feedback on just correctness. You want feedback on the quality. Is it fast? Is it done well? Can it be done better? You want the tooling to become more and more intelligent and answer the questions that the developer cares about, which is, how am I doing? Can you tell me ways of doing things better? So I love this. I stole this from my colleague, Baron Roberts. The only valid measurement of code quality is WTFs per minute. And I think that's very true. OK, so you have your development environment set up. Now you want to develop code. You want to make some changes. You have a bug you're trying to fix. You have a feature you're trying to add. Or you have some infrastructure you're trying to build and enable. So you simply go and you say, OK, start developing this. And today there's this ungodly processes in enterprises where it's like, OK, so you have to go do this, then you have to go to Jira or whatever your ticketing system is. You've got to click, OK, start progress. You've got to go to a different system and start logging your time. You have to do all of these different things. But really, it's all one logical thing, which is I want to start developing. I want to start doing work now. So it's one simple thing. And you can imagine this being abstracted in a great product where it simply is, start working on this bug. Start working on this feature, and everything gets set up. Again, the developer doesn't know about this, but we need to take care of the ticketing system, if there's time management. Let's say this is on an hourly basis. We need to take care of the time management. We need to take care of the branching model. So create a local branch, manage that local branch, when to merge the branch into master, when to fire off a code review. All of these things we take care of, the product takes care of. And then lastly, you have a change, and you want that change to go out to your customers, to your audience. I call it push, but it could call it whatever. The biggest thing here is that software code is not text. So if you go to most code searching engine, you go to most places, code review tools, they treat code as text. They give you textual diffs. They don't give you semantic diffs. They don't tell you what's changed. So by treating code as code, by having the semantic meaning about what the code is doing and what changed semantically, you can provide a much higher level, much higher quality review or change log or release notes. So you're starting to see companies, there's a company in San Francisco, SourceGraph, that does semantic code hosting and indexing. But a very simple thing would be, when you're doing a code review, do you go to a diff viewer and do your code review? Or does the code review happen in your development environment? Do you see the code running as you're doing the review? Do you get the feedback about the quality? Do you treat the review or the code under review as if you were developing it yourself or not? And I know at least at LinkedIn today, we force engineers to do this unnatural thing of going to a separate viewer, looking at textual diffs, and then somehow doing a review on that. And we want to change that. So once you've gotten through and you have great products that have up-leveled the abstraction, has made this next generation of software developers productive and democratized it so people are not afraid of software development, or they don't need to be of the engineering personality. What could we do if this was a reality today? So I think we are today limited by our ability to execute, not by our ability to dream. So I picked 2 examples here that are so easy for us to imagine how we could do it, and we know we want to do it. Go to Mars and have, in medicine, have nanorobots that can travel through our bodies and automatically detect things like cancer cells or artery blockages and deal with them. They're so easy for us to understand the value of doing that and why we want to do that. And we're working towards it, but we're limited in our ability. And I think really, when you think about the promise of this golden age and democratizing software development and where our kids will be doing software development and building these kinds of systems, these are the kind of problems that we could solve if we can get there, if we can build great developer infrastructure products. And that's what I had. So I specifically tried to make this talk relatively brief. I'm not a big fan of droning on for 45 minutes. I think about 20 minutes is right. So I'd be happy to take any questions. And if not, you can have you can have some time back from your very busy day. Yes, Baron.
I think today, to your point of democratization, today we're everything follows sort of a hype curve. If you're familiar with a hype curve, it's like there's the ultimate promise at the trough of despair, and then we sort of rise up to the reality inside. So we're not in the height of the hype curve. How would you recommend we all work through that inevitable trough of despair when people realize anyone can program, but it's still a machine, it's still hard, right?
Yeah. Well, I think that some things are on the upscale of the hype curve, certainly like Docker and containers and things like that. I think some things have actually crested and are on the way to greatness. I mean, I think cloud computing, whether you like that term or not. What Apple has done with iOS development, and you see the people who are not software engineers, but who are building iOS applications, and then those iOS applications are tremendously successful. I think those are that's not hype. That is transformational, the smartphone. So I am actually not too worried about that. I think we're doing a good job. There are always going to be people who are very early movers. There's going to be the big majority. Just like I think electric cars are entering the early majority, I think things like cloud computing and application or app development, for a smartphone app development, are in that majority phase. I actually think, the hype today gets magnified because we have all of this we have all this communication. Right, we have the Twitters and the Slacks and everything. So just like the news cycle is becoming hyped, I started off with kind of a joke about Donald Trump. I think in 50 years ago, Donald Trump, there's no way, first of all, he's the presidential nominee, but there's also no way that he gets the kind of publicity that he's getting today. And so I think the whatever 90-second soundbite, we fall victim to that ourselves as well in the software development space. So my recommendation on that is stop following the 90-second news tidbits. Stop the tweets and the 140 characters. Read books and things that are well thought through, that are mature, and learn from those instead of kind of the hype machine. Yeah.
Do you have an example with people reviewing code with diffs?
Yeah. Text diffs.
Text diffs. This is a pretty good abstraction to see what actually
Mm-hmm.
Do you have suggestions on how you do that?
Yeah, I mean, we actually have concrete examples at LinkedIn. One is when let's say that you're changing an application that has a front end, that has a product interface. So we actually automatically capture the screenshots of what's changed. And we present that. So we say, here, product manager. So this allows a product manager that does not write code, that does not understand the software, but understands the product to say, hey, like this doesn't make sense. We decided that the product was going to behave in one way. I see from your changes behaving a different way, right? So that's semantic review. And then you can have your super duper distributed systems programmer go through and say, oh, we should modularize this. We could change the API in this way. So they could work on that diff. But you want to provide all of that. So that's just UI is an easy example because you could actually take screenshots or videos. So we even have videos we'll have screencasts of, let's say, an integration test, a functional test running, and the product manager can go in and play that screenshot. And it's pretty cool when the CEO of your 10,000 person company, who's also a head of product, like reviews the product change, watches the video, and says, this rocks. This is an awesome change. It's also pretty cool when he says, like, yeah, I think this was a good idea, but now that I see it, I think we can make it even better. Yeah.
Quick question. So with Microsoft's acquisition of LinkedIn, going forward, I know that's been reported to the press, one of the major reasons is to integrate Office with a lot of things and everything like that. And internally, I can only imagine with the Gradle type system and everything that's most likely not Microsoft, going forward, and Microsoft internally uses things that are other than Gradle, like MS Build and things like that.
Mm-hmm.
How do you foresee like the merger that's going to go on, like
Mm-hmm.
in Gradle to start building a lot of these .NET applications or adopt MS Build, or what do you see that's going to happen in 5 months to a year?
Well, I think nothing's going to happen till the deal closes. Nothing can happen legally and regulatory till the deal closes. So that's, I believe, kind of forecast to close towards the end of the year. After that, I think that it's key that LinkedIn is going to operate as an independent company. So we're going to be kind of thinking about all those things. We'll have the opportunity to use those things if they make sense for us, and we're going to have the opportunity to not. So we'll have to see what makes sense for us to use and not. I don't immediately foresee switching to, let's say there's one part of Microsoft which is the Windows.NET, that programming stack, that environment, the PC age. I don't immediately foresee that being a big player. Yeah.
Do you see your team and teams around you kind of changing their charter from like more tactical tooling, one-off, just addressing specific issues, to more of taking a step back and looking at the whole experience and how we make it better for our engineers?
It's not a change. We have been doing that. I think our ability to is improving. So as I mentioned, when I started at LinkedIn almost 5 years ago, we didn't have there might have been something like lightweight containers, but if it was very early. It was not on our radar. We didn't have, Gradle was in its 0.x state. So our abilities, the tooling that was available to us, the thinking, the processes, the maturity wasn't there yet. So now we are able to think about it in much more concrete terms. These are dreams that we had, but today we're actually working on them. We're making progress on them. Everything that I talked about here today are things that we are working on right now. And we're, day by day making improvements on them. Yeah.
So you were talking about the future of development and about this kind of developer that doesn't always go on inside its own.
Yeah.
With see a smooth continuum where people can actually start at one point and move gradually towards the other? Or do you think we're building categories like now very few people know Gradle and people that know Gradle can know micro application?
Yeah, yeah. No, it's a great question. And actually, I made a small point about this, but I didn't highlight it, that we, here, we are that. And just like we don't spend a lot of our time thinking about, let's say, maybe Verilog or hardware verification or even what's going on inside the computers that much. It's been a long time since I've had to go to the level of, let's say, registers or L2 caches to figure out what was going on, right? The tooling, let's say the JVM, et cetera, are getting a lot better. But I think I mentioned it, I think our goal should morph from being kind of making our products better to becoming invisible. Just like the hardware engineers are invisible to the vast majority of people using computers today, right? And the vast majority of people using computers today are actually using something they don't even call a computer, they call it a phone, right? And that should be our goal. That's not something that's going to happen in the next couple of years, but still, that's what we're working towards. I think we know we will have gotten there when people stop thinking about developer infrastructure. That's just there, right? They fire up their Xcode or like iOS development environment. They fire up their Java development environment, Android. Actually, I think Android Studio is a good example of that. I think no question in the next 1 to 2 years, you're going to be able to work with Android Studio and probably not be aware that Gradle is running underneath the hood, right? So that's the kind of thing I'm talking about. For us, what that means is we have to be comfortable with being invisible. We have to be proud of the fact that our stuff just works. And there are still people working at Intel and AMD and NVIDIA and things like that today, and they're smart people and they're doing great work. There's still people building bridges and roads and buildings today, but we don't think much about them, and those people are kind of, they're comfortable in that role. All right, thanks everyone. Enjoy your day.